All right, here we have another equation that is in vertex form, and I want to graph this parabola, and let's state a few properties too along the way. If I take a look at my vertex form, I've got the a, the h, the k. The a is going to affect the shape, and right here my a value is -2, and that tells me two things. One, the fact that this is negative says that this thing is going to be concave down. So it'll be opening downward. And the other thing that it tells me is that this is going to be a narrow parabola, or at least narrower than the parent function, since that negative value is bigger than -1. First thing I want to do when I'm graphing this thing is I'm going to have to make a table. And in order to make the table, I need to identify the vertex. So I take a look at the 2 and the 3 here. This is going to give me a vertex of -2. I want to take the opposite of that value, and a y value is going to be +3, the same sign here. So that's my vertex, and I'm ready to make a table. And in the very center of my table, I'm going to put my vertex, so -2, 3. And why don't we put -2, 3 on my graph while I'm at it? -2, oh, that's up here. All right, and then the next step is to fill out my x values with a couple of points on either side of -2. So I can go in this direction, -1, 0, and in this direction, -3, -4. So I'm just going to find out these y values by plugging in these x values and solving for y. So I got a lot of stuff going on here, writing over it. Hopefully I'll get this equation written down correctly. Let's try this here. So let's plug in -1 first. Y equals -2 times -1 plus 2 squared plus 3. All right, and what's important here is I need to follow the order of operations. So before, I can't multiply this -2 or distribute it in there or anything like that because I have an exponent acting on this entire set of parentheses. So I got to make sure that I take care of all this stuff first. So we're going to take care of the parentheses first. And I'm going to get a -2 times, this comes out to be a 1, squared plus 3. Next step will be to square the 1, and that's pretty straightforward. That is 1 plus 3. And let's multiply -2 times 1 and add 3. And that's going to come out to be y equals 1. So that will be my y value when x equals -1. All right, so let's do that again. I'm going to see if I can delete all this stuff. Yep, okay, well, almost all of it. And we're going to do it again, and this time we're going to plug in 0 for x. So I've got y equals -2 times 0 plus 2 squared plus 3. And again, I want to start with parentheses here. So I've got a -2 times 2 squared plus 3. Next, let's take care of the exponents. Y equals -2 times 4 plus 3. So y is going to equal, this becomes a -8 plus 3. When I add those two, I get y equals -5. And here is my y value when x is 0. And remember, what's nice about this is there's a pattern of reflection here, and it's going to repeat. My y values will repeat on the opposite side of the vertex. So this is going to be a 1, just like this one was a 1. And this one's going to be a -5, just like this one was a -5. If you don't believe me, you're welcome to try plugging these in, and you should find that these values do come out to be the same as these values. So since we've got our table, we're ready to plot. Let's plug in, let's plot this point here, -1, 1. And let's plot 0, -5. Let's plot -3, 1. And let's plot -4, -5. And that looks like this right here. So let's connect the dots, and here is my parabola. And just as we expected, this thing is concave down. It is narrower than the parent function. I can list a couple of properties here. The domain, again, will be all real numbers. All my x values can be anything. My range Now this is going to be, it looks like I've got a ceiling at 3, and my range is all my y values. All the y values, if I were to pick a point at random on this shape, it will always be either 3 or below 3. It will never be above 3, so my range will be y is less than or equal to 3. Everything from 3 down is a part of my range. Let's see, what else? I've got an axis of symmetry that goes through the vertex. And that axis of symmetry is going to be given by the equation x equals -2. I could say that I have a max. Since this is the highest point on my graph, the max is at, the y value is 3, so the max is at 3. And I already said concave down, it's narrower. And then as far as increasing, decreasing, I could also describe those two things. Let's see, if I'm talking about when the graph is increasing, I want to imagine that I'm riding the roller coaster that is this parabola, and when am I going up? Well, let's see, if I start over here, I'm going up, I'm increasing, I'm increasing, I'm increasing, and then boop, I stop increasing here. So how do I describe everything from the left of this point? Well, to the left of -2, all my x values will be less than -2. So I'm increasing when x is less than -2, and I'm going to be decreasing on the other side of this thing. So once I pass that vertex, I'm going to be going downwards, and x will be greater than -2. And that looks like we've covered all the basics for our properties, and there you have it.